So I'm recording this. This is technically video number 2 on simplifying rational expressions. On today's video, we're going to be multiplying and dividing rational expressions. So we've already simplified rational expressions. We're now going to multiply and divide rational expressions. And tomorrow, we're going to do complex rational expressions, which is the same thing as dividing rational expressions. So let's jump to the same worksheet that we were working on 8.1. We learned how to factor to be able to cancel things out, and we even did 1 and 2 on the previous lesson. Key concept was that you could only cancel when you have multiplication, and when we don't have multiplication, we use factoring to be able to get multiplication and be able to cancel. Let's move on to questions 3 and 4. You see, on 3 and 4, we actually have 2 fractions, and we are multiplying them and dividing them, okay? So what's the difference between having 1 fraction? How do we solve that? We would factor everything possible and then cancel things out. How are we going to do this one? Same thing. We're going to factor everything possible and then cancel things out, okay? So there's nothing new to the lesson. There's just a couple more things to factor. So since this is a pure multiplication, well, actually 1 fraction times another fraction, I'm going to put the first fraction right here times the other fraction over here, and I'm going to factor anything possible, or better said, everything possible, because on the top left, on the numerator, we could factor something right there. What could we factor? X, okay? Thanks for participating. What's left over on the inside if you pull out an X? X plus 3, thank you so much. Okay, how about down here? You can't pull out a GCF, but that is a quadratic trinomial where the a value is 1, the c value is 2, and the b value is -3. So when your a value is 1 on a quadratic trinomial, usually we set this up, put an x right there and an x right there, and we think what times what is the c value 2, that if I combine together is the b value -3. And I usually say make a list, but you can't really make a list of the multiples of 2. It's just 1 times 2, right? So what numbers belong in here? -2 and a -1. Thank you. All right, so we have factored this bottom one. We factored the top one. Now let's go to this one. Let's factor that one. Over here, we have a quadratic trinomial. Again, the a value is 1, c value is -2, b value is -1. So jump right into our factored form format with x, and we think what times what is -2, the c value, that if I combine together is -1, the b value. So what numbers belong in there? +1, -2, or -2, +1, doesn't matter the order, as long as you have the right pair of numbers, right? And last but not least, let's take a look at this one down here, x squared plus 4x plus 3, parenthesis, x. What times what is 3, that if you add together is 4? +3 and +1, right? 3 times 1 is 3, and 3 plus 1 is the middle value, 4. Are you with me? So, just like the previous lesson, how do you simplify rational expressions? Factor everything possible. We already did that. Cancel things out. So let's cancel things out. What do we see that's identical up on top and on bottom? And it doesn't have to be right on top of each other. As long as it's in the numerator, either this fraction or this fraction, it could cancel with anything in the denominator. So what do I cancel first? X plus 1, this x plus 1 right here with this x plus 1 down there. X minus 2, this guy over here, x minus 2 up on top, cancels with the x minus 2 on the bottom over here. And the x plus 3, right? This x plus 3 cancels out with that x plus 3. So what do we have left? We have an x up on top and an x minus 1 on the bottom. And this is our answer. Pretty easy, huh? So we're not really learning any new steps. There's just more items to factor. Before you would have like a single fraction, and you just focus in on this, and you would factor the top, factor the bottom, you cancel whatever you can. But now we have more things to factor. We factor every numerator, we factor anything possible, or factor everything possible, right? And then cancel things out. It's that easy. So multiplication is cake. Division is just as easy. The only thing you need to remember is that when you divide by a fraction, you're really multiplying by the reciprocal of that fraction. Okay, I don't know if you want to write this down or not, or in your own words. When you divide by a fraction, you're really multiplying by the reciprocal of that fraction. Okay, what does that mean? Only what you're dividing by flips, the second fraction only. Okay, so I mean, this is a lot of words to jot down right now. Okay, maybe you just want to see it in action, and then you could write down in your own words what's happening. Okay, so whenever you have a fraction divided by a fraction, the first fraction is going to stay exactly the same. I'm going to put a black fraction bar, but I'm going to circle this division sign, and I am going to make that a multiplication sign. The division changes to multiplication, and the second fraction flips. Okay, the second fraction flips. So right here in blue, I want to have my new flipped fraction. Now, I could write x squared plus x minus 12 up here and x squared plus 8x plus 16 down here. I could do that right now, just flip them. But instead of that, I might as well start factoring as I flip it. Does that make sense? So let's start factoring. So this guy down here, that's an easy quadratic trinomial to factor. And notice I'm writing it on the numerator. Why? Because I need to flip the fraction. I need to flip this fraction anyway. So I'm going to write the factored form up here. And I have x. And how do I actually factor this? I need to think what times what is my c value, negative 12, that if I combine together is my b value of positive 1. Okay? So you might want to make a list, negative 1 times 12, negative 2 times 6, negative 3 times 4. And what numbers belong in there, in the parentheses? Negative 3 and positive 4, right? If I add those together, it actually gives me the positive 1 that's right there on the b. So there it is, negative 3, positive 4. Now, I'm going to factor this top one, but I'm going to write it on the bottom because I need to flip the whole entire fraction anyway. So let's actually do that. Parenthesis, x. And again, I want to think what times what is 16, that if I add together is a b value, in this case 8. You might want to make a list. 1 times 16, 2 times 8, 4 times 4, 3 didn't work, 4 and 4. So plus 4 and plus 4, because 4 and 4 works, right? If I add 4 plus 4, I actually get that middle value, positive 8. So all I did was plug in those 4s into the spots down here. Anyway, out of these two, the numerator or the denominator, which one's easier to factor? The denominator. Okay, so let's do that. I want to do this one in green. Parenthesis, x. That's an ugly parenthesis. What times what is 9? That if I combine together is the middle value, negative 6. Negative 3 and negative 3. All right, great. Now, this one up here is definitely way more challenging. Why is that? Yeah, the a value is 2, which means you're going to have to start by doing a times c, and then you make a list of the multiples of that answer that combine together to give you b, and then you do that setup of ax. I don't know. I want to demonstrate how to do a good guess instead of that multi-step process. All right. You know what? Let's do the multi-step process first, just to show everybody how we used to do it. So I'm going to multiply. Step 1. Multiply a times c, and that'll be 2 times negative 4, which is a negative 8. And then step 2 is to think of the multiples of negative 8, negative 1 times 8, negative 2 times 4, and that's about it, right? Now, which pair of numbers combines together to give me the middle value 7? Negative 1 and 8. I don't even have to change any signs. It's ready to go. So then you go to step 3, which is the setup. The setup is parenthesis, ax, and in this case, it's 2x, right? 2x. And then I get my pair of numbers from step 2 and put the negative 1 right there, and take the positive 8, put it right there. That's step 3, the setup. Step 4 is magic time. What do I mean by magic? Divide by whatever you can. 2 and 1, you can't divide by anything. So that first binomial will be 2x minus 1. You don't have to do anything. You could technically divide by 1 if you wanted to. The second binomial, I could divide by what? 2. By 2. And what do I get? X plus 4. Perfect. Now this is the factored form, which belongs right here in the numerator. And then I could cancel everything out. Does that make sense? Okay, now I want to pause right here before finishing the problem. I want to pause right here and show you kind of like a way to guess that might make it faster. So let's pretend that you forgot this multi-step process. And let's just look at what we have here, and let's not do this yet. I'm not going to factor this yet, okay? So what would cancel out already? The x plus 4 up here with the x plus 4 down here. Okay, what else? The x minus 3 up here with an x minus 3 down here. So we know that this guy should get factored. We would like it to get factored. And what would you like to have in one of these binomials? Either an x minus 3 or an x plus 4. I would like to have an x plus 4 right here or an x minus 3, right? Now, if I thought x minus 3, I'd have a 3 right here, and 3 times some other number needs to give me negative 4. Is that going to work? Is the negative 3 right here going to work? No. So x plus 4, I'm just going to write it, and this is a guess. I don't know if it's working yet, but there's my guess, x plus 4, which means that if this is a 4, what number needs to be here that when I multiply it with the 4, it becomes a negative 4? What needs to be right here? A negative 1, right? A negative 1. Okay, and if I have an x here, then what has to be right here in order to, when I multiply them, get 2x squared? 2x, okay? So do you guys see how I just guessed at it? Now, I'm not sure if this is right, okay? I'm like, I hope that one of these binomials is up here, and it looks like x plus 4 is the only one that works, so I wrote it, and then I figured out what the other one would have to be. So, but since it's a guess, I need to check it. Let's actually check it. So what is 2x times x? 2x squared. What's 2x times 4? 8x. 8x, but what's negative 1 times x? Negative 1x. So 8x take away 1x, is that positive 7x? So I know it works because the last one, negative 1 times 4 is negative 4. So I've guessed and I've checked it and I'm done. Does that make sense? So I don't know, guessing and checking, it might be faster than doing this 4-step process, even though I call this the shortcut method, right? So you might guess and check. As you can see, look, it's the same exact binomial times binomial that we had. And I did it by guessing, by being hopeful, right? So I wanted to show you both ways. Now that everything's completely factored, let's continue canceling. The x plus 4 down here will cancel with the x plus 4 up here. So the only thing left in your answer is 2x minus 1 up on top over x minus 3 on the bottom. Okay, so again, what we learned here was that when you divide by a fraction, you really multiply by the reciprocal of that fraction, right? Even if I were to tell you 20 divided by 2, let's think about this. The number 20 divided by 2, you could make the 2 look like a fraction. You could put it over 1, right? And then you would have, we already know that 20 divided by 2 is 10. We already know the answer. But you could technically take the 20, rewrite it, and then change the division to multiplication and flip that fraction, and it'll become 1 over 2. And we all know that 20 times half is the same thing, 10, right? So that is a truth in math, that when you divide by a fraction, it's really multiplying by the reciprocal of that fraction, no matter what your situation is. When you divide by a fraction, you really multiply by the reciprocal of that fraction. All right. We have this worksheet that's on Google Classroom, so I expect everybody to take out their Chromebooks and work on this once we're done explaining some examples. Right now, you might want to just copy down some of these questions. This worksheet, by the way, it's 2 pages long. We're going to do 1 through 21, all of them, and we're going to spend 2 days on it, okay? Now, some of these are ridiculously easy. I'm talking easier than what we were doing yesterday and the day before yesterday. Why? Because if you look at number 1, might as well copy it down if you want. Number 1, there is nothing to factor. And remember, what did we learn this lesson? How do you simplify rational expressions? Factor everything possible and then cancel things out. But you see, on this one, it's all pure multiplication already. There's nothing to factor. Since there's multiplication, 9 times a squared times b to the third divided by 27 times a to the 4th times b to the 4th times c. Since it's all pure multiplication, you can just start canceling things out. Okay, so what would you guys like to cancel? The 9 and the 27, right? 9 over 27, that fraction would reduce down to 1/3. 9 divided by 9 is 1. 27 divided by 9 is 3. Are you with me? Yes. And then we move on to a's. How many a's do we have up on top? We have 2. How many a's do we have on the bottom? 4. So all 2 of these a's will cancel with 2 of these, and we're going to have 2 left over on the bottom. Okay? How about the b's? There's 3 b's up on top, 4 b's on the bottom. All 3 b's cancel with 3 of these, and there's going to be 1 b left on the bottom, which you don't even need to put to the power of 1. It's just a b. And there's also a c left over. Now, what is my answer then? What's left up on top? 1, right? So I need to put a 1. I think some students make this mistake that they see everything cancel up on top and they say, oh, the answer is 3a squared bc. But that's not the answer. That's the denominator of your answer. If everything cancels out up on top, you have to put a 1 up there. Okay? So what do we have on the denominator? We have 3a squared b to the 1, which is just b, and c. So this is your final answer for number 1 on your homework. Pretty easy, right? Okay, and it's super easy because we didn't have to factor anything. In all reality, we're probably only going to have one of these easy questions where you just cancel things out. Okay, even if you have, like on number 2, you have parentheses with an exponent, that's nothing difficult. Just remember you need to distribute the outside parenthesis because it's all pure multiplication. So distribute the outside parenthesis. That 3 goes on to the 2, and that's 2 to the 3rd, which becomes an 8. When you go 3 on the 3, power to a power multiply, you're going to have m to the 9th. 3 times 2 is 6, n to the 6th. And it's over negative 18, m to the 5th, n to the 4th. And then you cancel out again. So I'm going to let you guys do that one. The answers are on Google Classroom, unless you want me to do it. Do you want me to do it? Or it's too easy, right? You guys got it? Yes. Or do you want me to do it? No. Just do it? Nike. All right, let's just do it. So let's reduce 8 over 18. What does that reduce down to? You could reduce by 2, and it'll give you 4 over reduced by 2, 9, right? And technically that's a negative 9, right? Okay, so our answer is going to have a 4 up on top and a 9 on the bottom. And you know what? This negative sign, instead of putting it on the 9, I'm just going to put it right here in the middle. Put a negative sign right there in the middle. And what else do I have? Well, I have m's up on top and bottom. The 5 m's on the bottom cancel with 5 of the 9, leaving me 4 up on top, m to the 4th. And there's 4 n's on the bottom that cancel with 4 of the 6, leaving me 2 n's up on the top. There's my final answer, negative 4 m to the 4th, n to the 2nd over 9. Let's get to some fun questions, though. Some that we actually have to factor. So number 5 looks like fun, especially because when people look at number 5, they freak out. Why? We're used to seeing the v squared first, right? Or the x squared first, and then the constant at the end. So right here it's flipped. So what should we do? We should flip it to the way we're used to seeing it. The only thing is, when you flip it, when you take the v squared and flip it over here and take the 25 and flip it over there, the negative sign belongs to the v squared. Okay, so check this out. I have my new fraction right here. I'm going to have a negative v squared plus 25, and it's going to be over 3v squared minus 13v minus 10. Okay, now, could I factor this? Not yet. Why? Because I want a positive v squared. I don't want a negative v squared. I want a positive v squared. So the trick to changing signs is to factoring out a negative 1. So check this out, guys. I am going to pull out a negative 1, and what will I have left on the inside? Positive v squared minus 25. Are you following me? Okay. And now, not only that, on the inside, I now have v squared minus 25. And everybody should recognize that this is what? It's a perfect square binomial, right? It's a difference of 2 squares. You could actually factor this. So let me actually factor that. we have the negative 1 on the outside. We have parenthesis, 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 parenthesis. And what's it going to be on the inside? V minus 5, V plus 5. Right? They have to be opposite signs. So when you multiply them, you actually get the negative 25. And they also have to be opposite, so when you distribute on the middle terms, they'll cancel out because there is no middle term. Right? So they have to be opposite signs. Anyway, this is my completely factored numerator. That took a while. That was my completely factored numerator. So this, we switched it. We factored out a negative 1, and then we factored out that red v squared minus 25 to v minus 5, v plus 5. Now I still need to work on the factorization of this guy. Now this guy has an a value of 3, a c value of negative 10. So I could begin with my steps. A times c, that'll be negative 30. Step 2, think of the multiples of negative 30. Negative 1 times 30, negative 2 times 15, negative 3 times 10, negative 4 doesn't work, negative 5 times 6. And then out of those pairs of numbers, which combine together to give me the middle value, negative 13? Negative 3 plus 10 is 7. Negative 10, positive 3 is still not negative 13. Negative 2 and positive, okay, so negative 2 and positive 15, that'll give us a positive 13. So at least we have the right number, we just have the wrong sign. So we want to switch the signs and we're all good. So plus 2 minus 15. Now third step is to do the setup, AX, AX, right? What is A in this case? 3 with a V instead of an X. So you're going to put 3V, 3V, okay? And what about the spots right here? We fill these spots with the numbers positive 2 and negative 15. Does that make sense? Positive 2, negative 15. Okay? And fourth and final step, I always say magic because we're going to magically divide by whatever possible. So the first binomial, the 3 and the 2, you can't do anything to that, so you're going to leave it 3v plus 2. And the second one we could divide by what? By 3, and that'll give us a v minus 5. Ladies and gentlemen, this right here is the factored form of this quadratic trinomial that had the a value of 3. So I get to rewrite that in the denominator of this other one that's already factored. So here we go. Parenthesis 3v plus 2, parenthesis v minus 5. And when we focus in on this, what could we cancel? V minus 5 and the v minus 5. And that's it. So my final answer to number 5 will be fraction v plus 5 over 3v plus 2. But this negative 1, instead of distributing it, I'm just going to put the negative sign out here in front of the fraction. So there's my final answer, negative v plus 5 over 3v plus 2. If you wanted to, you could have distributed the negative 1 in, and you would have had a negative v and a negative 5. So no more negative out here. You could have had a negative v and a negative 5, but I would leave it like this. Always leave it in factored form, I would say. So that's one of the harder ones that there is. But then again, we still haven't multiplied or divided. So we have all these other ones to practice with, and these are all multiplication. So again, what do? You go through and factor everything possible. And then after that, cancel things out. Why? Because we have pure multiplication. All right? So that's what we're going to be doing. And then we also have on the second page some division. Some are ridiculously easy because there's nothing to factor, right? Some you do have to factor and then cancel, right? But all these division ones, you have to change them from division to multiplication and flip the second fraction. Would you like to see any of those? Yeah. Which one? Number 17. Dang, that one's a doozy. All right, so number 17. What do? What happens with that division sign? Change the multiplication and you flip it. You reciprocal that second fraction. Okay? as I reciprocal, as I flip it, I might as well factor it. The denominator, s plus 4, you can't do anything with that, so I'm just going to rewrite it, s plus 4 up here. But notice that I wrote it on top instead of the bottom. Now this other guy, I could factor this guy. What's that going to be? S, what times what is the c value 25 that if I combine together is the b value negative 10? Thank you. Negative 5 and negative 5. So we have s minus 5 times s minus 5. Now, the first fraction's not going to change. That's why I'm writing it in black. And maybe this s plus 4 squared, you might want to write it as s plus 4 times s plus 4, but not actually distribute. Don't distribute and combine. Just write it, that binomial written twice. Why? Because we're now going to be able to cancel with that one and so on and so on. Okay? Now, do you guys want to do the multi-step process, A times C, and then go through all that? Or do you guys want to give it a good guess? What do you think? Good guess. Okay, so to give it a good guess, let's cancel whatever we can right now. So what could I cancel right now? The s plus 4 and the s plus 4. Yeah, it looks like a 5, sorry. And then that's all we could cancel, right? Now, this top one up here, I need to factor this guy up here, and I would like maybe right here to have a s plus 4 or maybe a s minus 5. Which one, a 4 or a 5, would work if you have a 15? Would a 4 work? No. A 5 would work though, right? So I'm not certain that s minus 5 is going to work, but I'm going to write it s minus 5. Let's see what happens, all right? So if I wanted to end up with a negative 15, what number must this be so that when I multiply it by negative 5, it becomes a negative 15? Positive 3, right? Now, if I have an s right here, I need to multiply it by something with an s over here. This times this, it needs to become 2s to the second. What do you think this is? 2s. Okay, so 2s. Now, that's my guess. We still need to check it. All right, so let's actually check it. What is 2s times s? 2s to the second. What's 2s times negative 5? 2s times negative 5. Negative 10s. How about plus 3 times s? That's plus 3s. A negative 10s and a plus 3s, that gives you that negative 7s that you have in the middle, right? And the 3 times negative 5 does give you negative 15. We have guessed correctly. So if you guess, you got to check and see that you guessed it right, okay? Now that I know that that it worked, now I could go and cancel s minus 5 with s minus 5, and that's about it. That's my answer. 2s plus 3 is up on top over s plus 4 times s minus 5. And I would leave it in factored form. I would leave it like that. But just in case you're in a different math class or you're taking a multiple choice test and you don't happen to see this, they might distribute this back in, combine like terms, and simplify this to a quadratic trinomial. But I would leave it like that. Okay? Anyway, that's what we're doing. We're going to stop right there because these guys, look at those. Aren't those beautiful? Look at that. Look at that. Ooh, sexy. Look at that guy. That's hot. Yeah. Well, this is actually nothing crazy. This is division of fractions. It's really the same thing. Because when you have, this is called a complex rational expression. Complex, it looks complicated. But you have a fraction in the numerator divided by a fraction in the denominator. All you got to do is remember that it's this top fraction multiplied by the reciprocal of the bottom one. But we'll get to that one tomorrow. We're just going to stop right there and focus in on multiplying and dividing fractions. Always remember, you got to factor first before canceling, okay? So open up your Chromebooks and let's work on this homework. Do as much as you can from numbers 1 through, see how far you get. Maybe you could get to number 18. That'd be awesome. That way we could work on the rest of these tomorrow. But try to do as much as you can on 1 through 18.